All right, we're going to talk about some polynomial division, specifically in this video, polynomial long division. So before we can do that, let's use long division with just numbers. So I'd like you to divide this by hand. So go ahead and put me on pause, and then we'll check your work after. All right, let's see how you did. I tried to color code this as much as I could, so we want to start by seeing how many times can 17 divide into 5. Which it can't, so we change that into how many times can 17 divide into 53? That would be 3 times 17 is 51. We subtract downwards. This is a 2, and we bring down the next number, which is 22. So, same thing here. How many times does 17 go into 22? That'd be 1 time. Subtract downward, and this process continues. So notice when we get towards the bottom here, we end up at the very end thinking about how many times does 17 go into 3, and it can't. So 3 ends up being our remainder, and then we put that over our divisor, which was 17. So just some important vocabulary here, and you're going to hear us refer to these terms all year long. We have divisor, we're dividing into. The quotient, of course, is the answer. Dividend would be, what we're dividing into. And then the last one, the last one here would be remainder. Okay, so this was our final answer here, 3,134 and 3/17. So we could also rewrite this in a different way as well. We could also say, I don't know why it keeps doing that. So this was our original dividend. We could also say that that equals 17 times what we got as our answer, that's 3,134, but don't forget to add 3. Okay, so this is another way, it's really understanding the whole concept of how multiplication and division and having a remainder, understanding how that's all related. It's just a different way to rewrite what we had just above. So now that we refreshed our memories of how to use long division with numbers, let's do it with polynomials. But first, let's try this one. We have x squared minus 5x plus 6 over x minus 2. And hint here is that we don't need to use long division. There's something a little more simple that we could do here. So let's see what you can do. So we notice that our numerator does factor. And when it does, we get the two factors of x minus 2 times x minus 3. And conveniently, our x minus 2's cancel, which gives me a final answer of x minus 3. So that was really nice and simple. But what happens when we get to cases where we can't factor and things just don't simplify out, just like our last time? In this type of case, we're going to have to use long division. So I'm going to have x squared plus 2 be my divisor. My dividend is going to be this x cubed plus x squared. Now here's something that you might not have remembered is we do need to have a placeholder for any terms up here that aren't present. So for example, there is no x term, so we need to have plus 0x. From here, the process is really similar to what we did when doing long division with numbers. So I want to think, what do I need to multiply x squared by to get x cubed? I need to multiply it by x. Because if I multiply x times x squared, I get x cubed. And x times 2 would give me 2x. And I'm going to line that up with the other x term. Okay, so again, I'm taking this term. I chose x because I wanted to find out, what do I multiply x squared by to get x cubed? Or in other words, that's the same thing as doing x cubed divided by x squared, which gives me x. Same concept. And then I multiplied to both. Now, key thing here is that we are going to subtract downwards, something that we oftentimes forget. So that cancels. I'm going to bring this down, and I get x squared minus 2x minus 3. Here we have a really similar thought. What do I multiply x squared by to get x squared? Or, similarly, I could do with x squared divided by x squared. Oops. And that would give me 1. So I'm going to multiply 1 to both of these terms. I get x squared plus 2. Don't forget that we changed the signs because we were going to subtract downwards. And this will come down. So now these cancel. That was the whole point. I have negative 2x. Negative 3 minus 2 would give me negative 5 or minus 5. And now we're left with a remainder here. So for my final answer, this is my remainder. How do I know? Because this degree is less than the degree of my divisor, so I can't divide it into anymore. So I'm going to have plus negative 2x minus 5 over my original divisor, which was x squared plus 2. So this is my final answer. And just like we did before, we can also rewrite this in a similar way. Just understanding the fact that when I have my function, it's equal to my divisor times the quotient plus the remainder. Okay, this is understanding what it means to divide and what it means to multiply, how they are related to each other. Another way we could write this oops. This is actually how we were given the problem in the first place. So remember, we had the function f of x divided by our divisor. This is like our given problem. So in this form, function divided by divisor. And we said that that was equal to the quotient plus the remainder over the divisor. So that's what this form right here is telling us. And again, that's just understanding that relationship. Oops. And then just one last thing for us to understand the difference between being proper and improper. Right here, this would be improper, and this would be considered to be proper. And why is that? Well, in this improper notation right here, something can still be simplified. It can be reduced or simplified in some way. Here, remainder over divisor, in this case, such as in examples that we've done so far, they have already been reduced as much as they can. So that would be proper. Okay, so I have one last example for you to try on your own. So follow the steps that we did before, and then we'll check our work. All right, let's check our work here. Big thing, if you already glanced and noticed that you didn't get the right answer, I would just double check if you had this placeholder for 0x squared. So a lot of times that's something that we forget, and of course it can definitely change the rest of our problem. So here, starting with x to the fourth. So I want to think, what do I need to multiply x squared by to get x to the fourth? Or another way to think of it is, what's x to the fourth over x squared? And that would be x squared. So I multiply x squared to both terms. I'm going to line them up based on their power, and I'm going to subtract downwards. So signs are going to be really tricky here. So I do the same thing. Next term I would have is 3x cubed, same concept, and I'm going to do that all the way through here. So I would suggest, again, if you didn't get this right, really spend time in looking at my work, especially pay attention to signs. But here was my final answer. I got x squared plus 3x plus 3 plus a remainder of 10x plus 7 over x squared minus 3. Just one thing to think about is I know that my original problem was an x to the fourth, and if I did multiply this x squared by this x squared, I would get an x to the fourth power answer. So just something to think about. So long division, it can be useful to find factors and zeros. We'll talk more about that coming up. And we want to divide by the term with highest degree, multiply, subtract, and repeat.